Good evening, I'm Jeff Lyons. This is the 14First Alert Weather Show at 9. It's Thursday night, July the 30th here, almost done with the month. And we have some rain moving in and some thunderstorms too. So I'm watching your comments. If you have any, shout outs, whatever it is, you can put them on there and we'll get to those midway through the show. It's a beautiful night out there. I don't know if you've been out. There's something blowing around though, making me cough a little bit. We have temperatures falling into the mid-60s tonight, and then increasing clouds, maybe some scattered showers by the afternoon, a better chance for rain later tomorrow night, and that will bleed into Saturday and maybe Sunday as well. And along the way, we could pick up a thunderstorm or two. For this evening, the active weather is to our northwest. Here we are down in the tri-state. So we have rain out here moving in toward Omaha, across central Nebraska, out near Lincoln. Kearney would be way out here. Scotts Bluff, right in there. These are all Marcia Yaqui towns, if you remember Marcia. And then farther north into South Dakota, we have other showers and storms, not severe at this point. That was the area outlook for severe weather for this evening. And then tomorrow, the outlook for severe weather shifts down into Missouri. Again, tri-state, no problems, maybe some rain, but that's about it. Saturday's interesting because as the front moves through, it could kick up some stronger thunderstorms, mainly over our eastern counties. And just to give you an idea, that would be like Jasper, Tell City, Owensboro, Hartford, maybe Madisonville. And the timing on this is a little odd. It might be overnight, Friday night going into Saturday. And I'm going to show you two models. Usually I don't give you a choice, you know, but tonight we're running a buffet here for weather. Usually I give you the meatloaf and that's it, but you have your choice tonight of meatloaf or tuna surprise. So we're going to start with the, this is the graph model, I believe. Let me double check that. Yeah, so this is our in-house model, the one that usually is pretty good with showing these events. And you saw some scattered showers move through Friday afternoon, and then it's depicting a stronger line of thunderstorms overnight that would be weakening as it crosses into southern Indiana and northern Kentucky. And then through the weekend, maybe some off and on scattered showers continuing. And as that low then spins through, it would kick up more rain on Sunday. All right, now we're going to look at the HRRR, the HRRR, High Resolution Rapid Refresh Model. This updates every hour. And to be honest with you, the graph draws from the HRRR, so all the models kind of work it out among themselves, and sometimes they do well, sometimes not so much. But anyway, there is agreement between the HRRR and the graph. The coverage-wise, the HRRR here that I'm showing you, a little more sparse with rainfall through Friday night, but it also has an early morning line of some showers and thunderstorms coming through and moving to the east, and then it is relatively dry for Saturday. Now the HRRR only goes out to Saturday. So what to make of this? I think that if the cold front continues as it has been in the plains, we will likely get a few of those pop-ups in the afternoon and then some sort of consolidated or more organized line of storms later Friday. I still think that overnight thing probably will be the one because of the motion of the front, how quickly it's coming in. The temperature will get a dent in it through the weekend, only up into the lower 80s. And again, that's because this is an actual cold front with some cooler air behind it. We dry out then Monday, but we could see a lingering chance for scattered showers and thunderstorms. The smoke today was a little more prominent this morning. You can kind of see that haze in the sky, and that gets us up to this evening. Now, I was out and home here between the shows, and it looked pretty clear to me. Now, the moon wasn't up yet. That's usually a good indicator. You know, if the moon looks really red, or orange, then that indicates a lot more smoke aloft. And as that cold front comes in, it may force a little bit of that smoke back through on Friday night and Saturday. Again, we're not expecting an impact on the air quality at the surface. So this is more just haze and optics as opposed to being hard to breathe. We're at 74 right now. It's calm. The current temps are all around 75 degrees across the tri-state, and the feels like temperatures also pretty close to the actual with the low humidity. We were down to 65 this morning, and we did get up to 86 this afternoon. That's still about 3 degrees cooler than the average, both high and low. And it is our second day in a row here in the mid-80s. We will finish out the month with a high temperature in the middle 80s and no additional rainfall. So the grand total on the deficit for rain here in July will be about 2.5 inches, a little bit more than that. Rain that we should have had but did not get. So if you're gardening, Jeff Miller and some of you others that are growing your tomatoes and watermelons and sweet corn and things like that, if you haven't been watering, you may need to start watering a little more. Although the drought monitor, not alarming in any way. There are no drought classifications on the tri-state and only little pockets of abnormally dry. You don't really get into trouble until you get along the East Coast, where we have ongoing drought there in South Carolina, and then the West, in particular the Rockies, Colorado, up into Wyoming, southern Idaho there, and Portland. And we have some fires in here too, which are adding to smoke out in that region. But here at home, at least for now, our rainfall is still acceptable or within the acceptable limits there by the U.S. Drought Monitor. Tomorrow, 84 for the high, and that would be ahead of the clouds and the rain. The cold front is still kind of angling across Nebraska, Colorado, and western Kansas right now. And it's all being held back by that high pressure, which will move into West Virginia, should be right over about Huntington by tomorrow afternoon. And that means then we have room to bring some rain in here. And again, this is the graph model, but a bigger picture of it. You can see that southerly wind coming up ahead of the front, which will transport moisture from the Gulf and make it a little more humid and enable those showers and storms. Then we get the late stuff coming in between, say, midnight and 6 a.m. There's your heavier thunderstorm activity to the east, which would line up with that marginal risk on Saturday. And then for the remainder of the weekend, that low kind of slows down a bit and continues to crank down some clouds and maybe some scattered showers too. The GFS was the first to kind of show the idea that we would have a spinning or cutoff type low over the tri-state, and it is kind of pulling away on that, but we still are showing chances of rain daily there through Wednesday and Thursday, and total rain with the GFS model for the week, that's the whole 7 days, about a half an inch or so, maybe a little more than that. The European model does have this spinning. If you look at the data here when I run it, you'll see it kind of go back and around, and that would keep us at least cloudy through both Saturday and Sunday with that chance of rain too. So I think the sum of all these parts is that we will have a line of thunderstorms and showers sometime late Friday night, early Saturday, and then kind of pesky ongoing rain for the rest of the weekend. I think Saturday will have the higher threat for rain, Sunday a lesser threat. So if you have outdoor activities, you're trying to throw a barbecue, or you've got a ball game or whatever it is, Saturday might be a little dodgier there, just with nuisance rain interrupting your regularly scheduled fun. 65 tonight, partly cloudy. It'll be comfortable again. 87 tomorrow. We will get some sunshine in the morning, but then it'll go away as the clouds thicken up. Rain chances will peak on Saturday at 70%, but a lot of that is between midnight and noon. And then Sunday, kind of ongoing scattered showers. Monday, Tuesday, Wednesday, same thing. We will get sun, and the temperature is going to start to warm up again too, so that in the longer range here through the 13th, we will stay warmer than normal and drier than normal too. And that is Geo, our pet pick for tonight. A happy dog there in the background. All right. Let me get your questions answered as best I can. Here we are, here we have it. So let's see. Jeff Turner, can I help us a bit when it comes to like the Doppler weather and the colors from the storm breaks out or the hook you talk about? Appreciate it. McLeansboro, Jeff Turner over in Hamilton County, Illinois. Yeah, well, how could we do that? Well, we can do it in real time. How about that? We'll do weather school right now. I'll go back to the radar. And I think the only issue is going to be, I don't think I have a single site. I'll explain what I'm talking about here. I'm just mumbling to myself, as I often do. Oh, rats, now it's gonna, okay, never mind. Okay, so, yeah, those are all gonna be out of range. Well, maybe not. You might get, I got Des Moines in there. Okay, well then in that case, we will try the single site reflectivity and we will zoom in. Okay, so you were asking about Doppler radar and the colors. And so I'm going to give you a little disclaimer here. The first is that that is very far from the radar, so it's an ugly return. Now, there are different ways that we look at the radar here that you don't see at home. And the reason we do it is because we like to look at the raw data. And so I'm going to show you the raw data as opposed to something that is somewhat smoothed out here for TV. And when I do that, you'll notice that now all of a sudden we have all these little squares in here, or pixels. So the way Doppler radar works is the beam, and this one is coming from about 85 miles away, excuse me, in Des Moines, and the beam on the radar is about a half a degree wide, okay? So if you think of a circle, we're a half a degree piece of pie, very slender, and as the beam goes out from the antenna site, it gets a little wider the farther it goes out. And so these little boxes that you see in here are what we call bins in the radar, and each bin has data in it. So when the radar energy goes out, it lights up, in this case, rainfall, and red would be your heaviest rain, green would be your light, yellow would be somewhere in between. It would be moderate rainfall. And each bin then, the data from that is run through computers on the radar itself, and that's how we determine rainfall rate. We also can determine a precip type, right? Whether it's hail or insects, birds, rain, snow, ice, combination, etc. On Doppler radar, when we look at velocity, we get velocity that far out. Sometimes the velocity is range folded, meaning after you get a certain distance away from the radar, you can't see it anymore, and you get a purple thing here. If you're using a radar app, like Radar Scope, Radar Omega, you'll see that purple, which is like the limit for what the Doppler effect can produce usable data. And so in this case, the rain, or the hydrometeor, particles in the atmosphere, are being blown away from the radar. Red runs away, green goes toward the radar. And at this range, it's really not as skillful there to look at things. I don't want to get too far in the weeds, but on the other hand, I don't want to tell you the wrong thing. So let me see if I can get a better radar thing here. And hang on one second. Sometimes it takes a minute for the data to load when we're at this range. So we would want the Des Moines radar. That is Des Moines. So we would want Omaha's radar. Okay, so I will load Omaha's radar in. I'll answer a bunch of questions, and by the time we come back, we should have some data in there. It takes it a couple minutes to come into my machine. Let's see here. All right, this is riveting, I know, but it's to an end here. It's with a purpose. We're trying to learn a little bit about the radar. So while I do that, I'll answer some other questions. What's it going to do Saturday in New Harmony? I have a bake sale fundraiser at the Main Cafe, so please no rain. This is Becky Doan. Well, it might rain on Saturday, but at least if it's the Main Cafe I'm thinking of, you got a little overhang there. They'd probably let you set up your baked goods in there. Can't speak for them, of course, but that would be nice if they would. Okay, so I am Still loading radar here. Okay, now we're going to get Des Moines in there. Actually, not Des Moines. We wanted, what was Omaha. Okay. There we go. So it'll take this just a couple of minutes to populate there on the radar. So we'll have to wait. And while it's doing that, we can mess around here with questions and comments. Okay. Oh, somebody was asking about roost rings. Oh, you're good. You want the deep dive. Okay, well, we can go into that too. All right, let me see here. Got to get the right eyes in here. Thanks for the weather update. Meatloaf does sound good. I make a mean meatloaf, and it's the simplest thing in the world. You know, it came out of some church cookbook at my grandmother's church, well, my church when I was a younger kid. And there's like 4 ingredients. You know, there's oatmeal, ground beef, onion. What's the other thing? Probably a little garlic powder and salt and pepper. Has to be some, oh, an egg, right, and a little milk. And you mash it all together. You put your oatmeal in, you get that loaf. Then you cover it with ketchup. You mash up some saltine crackers in the oven, and it bakes in a hot oven. I think it's 425 for like an hour. And it is good. And you don't do it in a loaf pan. You do it, you put it like in a baking dish, and you make your loaf, you know, and then that grease comes out and you get rid of that. Does that sound like a credible meatloaf to you? I can't give you the ratios. I think it's 1.5 pounds of ground beef, a cup of oats, and then probably a teaspoon of salt, teaspoon of pepper, and an egg, and I think it's 1/2 cup of milk. For those of you following along at home, then we'll open the other oven, and this is what it should look like. Okay, Justin Turnage, what's my thoughts on models missing some data? On Father's Day, it was a wake-up call. 2% tornado mini outbreak occurred. Yes, sometimes you get those surprises, and I think what you're talking about might be the inputted data, the lack of certain weather balloons and other stuff. Which could have certainly have an impact on the quality of the model data. We have seen in this last year and a half now, the models have been a little less reliable than maybe in the past. But again, you know, that's one variable, the lack of weather balloon data that you would factor in. There are many other things. I mean, the weather can be unpredictable too. Models never caught everything. Jeff Miller had 6.8 inches of rain so far this month. Well, you're not in a drought. You should be doing all right. Let's see, Justin again. Looking at long range, a heat dome builds Death Valley could break day and nighttime records. That's true, but that is out west, right, in the Mojave Desert and so forth. Leslie Hibbs, watching from Madisonville. Well, I'm glad you're on there tonight, Hopkins County. Cheyenne Hammond, severe risk pretty low, as asking if it is. Yeah, I think it is. Joe Avery is, looks like a string of profanity. I can't decode it there, but anyhow, not sure what you're irritated about, but I'll be happy to try to fill you in. Justin Turnage, roost rings are awesome to see in the morning. Also, radar picks up smoke from fires. It does indeed. Roost rings occur when we have, usually in the morning and sometimes at night, when the sun comes up around lakes and different places, these birds will take off. Have you ever been out, even, you know, in fields and that, you'll see these huge clouds of birds that go up. Well, those birds also show up on the radar, and it looks like a ring propagating out from the radar. As the birds get higher and move out, then it shows up in the radar. So yes, we can see that. We can see locusts, all kinds of stuff. Let's see. Yvette McKnight, stormy weather, sunny mood. Yes, indeed. Always look on the sunny side, right? Okay, I think that's everything else. I'm going to try to do our little radar school here. Not sure if we have the data I want yet. We're still waiting for Omaha to populate there. Maybe it will here if I go back to the home view and then come back in. it takes a while for it to come in. Oddly, you know, the system that we use here at the station, like on radar scope, I could look at it instantly, but for whatever reason, the way the data flows down the pipe for us, it takes a few minutes for it to load up and to get in there. So hopefully we'll get Omaha churning here in just a second. And then the whole point here is that we'll have higher resolution pictures of the radar. So back to the gentleman saying, I think it was Jeff Turner over in McLeansboro. Let me make sure I got your name right. Thought I had it right. Okay, well, maybe I don't have it in here. I just saw it. How'd that disappear? Well, anyway, we are still waiting for data. The good thing about Doppler radar, of course, is the basic function, which is that it can determine wind direction toward and away from the radar. That's how we see rotation in thunderstorms, tornado signatures, and things like that. When dual pole radar came in, dual polarization, basically what the radar does is it slices it once this way and once that way. That's the different poles, right? So you're looking at the storm not only in planar mode, but also vertically. And so by combining those bins in the whole volume scan, now we can determine precip type, which wasn't completely possible before. It can discern between graupel, hail, rain, snow, wet snow, large hail, very large hail, and things like that, insects, biological, and others. And dual polarization is also very good for some of the derived products. And by derived, it takes other things in the radar and then it creates a product. And one of those is correlation coefficient, which is the way we detect debris. And what that's doing, because it's looking at what's falling through the atmosphere in two planes, it can say, well, hey, that's a 2x4, that's not rain, or it wouldn't know a 2x4, but it would know it was something that didn't belong within the field. So if you have just regular rain falling, all the hydrometeors pretty much look alike. And so you would have a very high correlation coefficient. In other words, everything out there kind of looks alike. However, if you get, tree limbs and corn stalks and 2x4s and cows blowing around, then the return to the radar doesn't look the same, right? It's like, well, what is all this stuff? And so that would have a low CC, or correlation coefficient. Well, we don't call it correlation coefficient on the air because A, it's hard to say, B, nobody knows what that means unless you do this job, and C, it's easier just to say debris detection because that's really what we use it for in a tornado situation. If a tornado is lofting debris into the atmosphere, then the correlation coefficient will see it. Hallelujah, we have radar data now. Just in time for a severe thunderstorm warning. So this is the live radar pic out of Omaha. Okay, and you'll notice a couple things right off the bat, I hope. First, that the little squares here are much smaller, meaning we have a higher resolution on the data. You'll also notice here we have strong winds inbound and weaker winds outbound. So just by doing a simple query of that data, we could determine, for example, how fast is that wind blowing. And when you see me do this on the air, I'm querying these different little bins. So it's showing 48 mile-per-hour winds inbound in this case. And again, you can't just take all this stuff at face value. You do have to look at the big picture. What's the environment the storms are in? Is it sheared? Is there instability? A number of things that go into it. And also distance from the radar, because as you get farther away, the data becomes kind of smeared out. The size of a bin, might be a mile wide at the end of the radar beam. So that means for a feature to show up, it would have to be 3 or 4 miles wide, right? It'd have to cover at least 3 or 4 bins going that way in order to see it. The other thing we can do with Doppler radar is, and I'm not sure that we're going to see one here, we're going to use a derived product. This is called VIL, or vertically integrated liquid, and that's what shows where hail might be occurring. And these are severe thunderstorm warnings, so there's pretty fair bet you're going to see some hail returns in there. So another thing we can look at, and we probably won't see one tonight, but you never know, would be a 3-body scatter spike. We're really getting in the weeds. And what that is, let's see. I have to go back here and turn the other thing on. And you'll notice we rarely would do any of this on TV because A, it takes too long, and B, nobody cares. Most of you just want to know if it's going to hail or if a tornado is coming to my house. But other folks, get a lot deeper into this. And of course, meteorologists, particularly at the National Weather Service who are issuing warnings, are looking at a wide variety of things on the radar. A lot more stuff than I look at or know how to interpret. And, but I can give you the meat and potatoes here, back to our meatloaf analogy. But what we would see if we have very large hail, sometimes you'll see a long streak in the reflectivity that kind of sticks out. It looks like a spike behind there. Now this is just a standard squall line, at least as best I can tell. And if we look at the velocity on it first, you can see those strong winds coming in here around Clarkson. This is again is in Nebraska. And so if we go back, and we're not going to have data to go back and forth with yet because it hasn't, the buffer hasn't filled up with data. But anyway, so those are a couple things. We can look at the CC on here. This is the correlation coefficient. We're going to call it debris detection. And at least at the moment, we're seeing pretty uniform hydrometeors, right? Stuff falling from the storm. I think we had another warning down there. No, we did not. It was just an advisory. So anyway, I hope that at least kind of gave you an idea of how the Doppler radar works. It takes a lot of practice and just looking at storms. There are many, many resources out there, including the National Weather Service has a great short course in interpreting dual pole Doppler radar data. And then there's a whole radar school that you can do it for free. Anybody can do it. And you can learn a lot that way. But the best way to get good at radar interpretation and understanding is just to use it. And I recommend either Radar Omega or Radar Scope. Radar Scope is a paid app. I'm not sure on Radar Omega, but the benefit is you get all of the products. So Doppler radars put out several tilts, right? Because the radar slices the storms at several different elevations, and then you would have all the different things that I've been talking about here tonight. All right, and I think there's like one person left in the room here. Nothing will clear out a room quicker than an ambush course on Doppler radar. Justin Turnage always looks at the raw data, yeah. 2011 WRAL, which would be Raleigh, has a dual pole. We could see debris from Sanford Raleigh EF3, yeah. The National Weather Service implement, okay. Let's see here. And again, Tori, I don't think we're looking at a severe weather threat for the weekend. Got it? Good. Okay. I don't see any other questions on here. But anyway, it's been fun talking shop with you here tonight on the radar. One other thing I'll show you, and again, I'm not sure if that data will be in here. I showed you velocity, and there are actually two kinds of velocity you can look at. And it's real important to use the right one and to compare one with the other. There are people who would, for example, if you weren't really looking carefully, or maybe even if you were, you would see this signature right here and say, oh my gosh, there's a tornado near Beamer. Why aren't they warning for it? They being the National Weather Service. Well, not so fast. What you're looking at is the straight winds, right? If we look at a storm relative velocity, this factors out the forward motion of the storm, and instead, that helps us to drill down and just see rotation. Now there is broad rotation there, but if we look at the data from each side or each gate, you'll see on one side there it's like 34, and on the other side it's probably going to be around 45 to 50. So that's pretty good rotation, but again it's pretty broad. And usually what you'd want to see for a tornado signature would be a couple of these pixels actually touching, where you would have the very bright, which would be higher wind speeds on the inbound and the higher wind speeds on the outbound touching, because that would indicate then a tight circulation or rotation. We see rotation like this all the time in rotating thunderstorms. But it doesn't always mean a tornado. And if you get on Facebook, you'll see the radar scope users group. People are always howling, why wasn't this warned? Well, like I said, there's a little more to it than just looking at the radar and saying, oh, there's a rotation. It takes a lot of skill and practice. Things do get missed, but not very often. Typically, it's going to be your EF0 or smaller spin-up tornadoes in a line that are much harder to detect. And the overall storm mode here, it looked like a squall line, not supercells. It is. So you've got that apex there on this is a bow echo. So that would be your strongest wind. And at the very top of it there, you'd expect to see a little notch here where you have inflow, right? Wind coming into that system. And then as this moves along, what will eventually happen in the life of like a bow echo like this or a segment is at the top end and sometimes the bottom, you'll have a vortice called a bookend vortice, one up here and one down there. And then you have this inflow jet pushing out right there, so you see weaker returns. So it's fascinating. I mean, you could spend a whole night doing this, and you learn a lot, you know, and while each storm is different, there are similarities from one storm to the next. All right? I think that's probably enough radar school, considering I got to go back and put something together here for the 10. Well, Deborah enjoyed that. I thought you were just here. I thought you were just here for the meatloaf recipes. Okay, well, good. Justin Turnage, gate-to-gate shear. Yeah, if you combine those, would you get the winds of the meso? Yeah, sort of. That's kind of like a spitball way to do it. There are more sophisticated ways that I'm not really as adept at. But yeah, that is the basis of it, where you have two gates, one in, one out, and you would add the values together, and you would get the gate-to-gate shear number. I think there's an integration that happens so it wouldn't be this the straight number. Okay, it probably has to factor out the forward motion, kind of like storm relative velocity damps that out too. Justin says that Radar Omega is a paid app as well. Okay, yeah, I wasn't sure. And again, I'm not connected with Radar Scope or with Radar Omega. I'm not selling them in any way. But if you're using like the 14First Alert app, you're seeing composite reflectivity, which takes everything that the radar is seeing, the whole volume scan, and portrays it. I can show you the difference on here. If we look at the composite return, it's going to look a lot bigger, and it actually shows the stratiform rain a little bit better, which is what comes behind a squall line, but you don't get the detail that you had with a single site. And occasionally composite will show rain where it actually isn't raining because it's seeing all the levels. So there could be rain up at, say, 40,000 feet that isn't making it to the surface, and it would show up as regular rain on your composite. So that's why it is good, you know, if you're trying to interpret radar data, to always use the closest radar site to the weather you're trying to sample, which is why I turned on Omaha instead of Des Moines, because this storm is moving in on them. And that's usually a pretty good strategy. And then you can compare and contrast. Sometimes you can look at the tops of the storms and everything else. All right, I've stood up and sat down like 12 times, so I'm going to stand up and sign off. How about that? I really appreciate your patience here tonight. Hopefully you learned a little bit about Doppler radar and how it works and how to interpret the images. And if that's your thing, go out there, Google it. There's a lot of great information. I could also recommend looking at, I can't think of the letters, COMET, which is, it's out of UCAR, the University Corporation of America, and you can take free courses on there as well. The Weather Service, EMA directors, people like that, use that site to learn weather forecasting skill, radar interpretation, fire management, all kinds of things. If you type meted.org, edu or UCAR, UCAR, I think, either org or something. Just put UCAR in a Google search and see where it takes you. UCAR weather, put that in there. Okay? Good luck. You got homework now tonight. So I'll see you on 14 News at 10 and again tomorrow here on the stream. Stay safe. Have a great night.